the common difference is, is the difference between each pair of consecutive terms in an arithmetic pattern, like in that example there. So this is an example of an arithmetic pattern. So the common difference in this example would be a 3, because the difference between this pair of consecutive terms, a 6 and a 9, is 3. And it's also the difference between this pair of consecutive terms, a 3 and a 6. So that's, that is why we refer to it as the common difference. And, the common ratio is pretty much, the same concept, but for the geometric pattern. So that's the number that we multiply each term by to get the next term. So in this case, our common ratio would be 1 over 3, because we multiply by 1 over 3 to get the next term, right? And the first difference and the second difference, we use those for the quadratic pattern, and we use in this example of a quadratic pattern, that line there, the 2, 4, 6, would be our first difference, and the second line would be our second difference. So there's a need to use the concepts of first and second differences to distinguish those two from each other. That's the unique thing about the quadratic pattern, because it not only has a first difference, but it also has a second difference, right? And I hope that's clear enough for you guys. And that brings us to the end of our lesson today. Now for our, trick question. Okay, let's see who got it. So here, okay, this is an example of a Fibonacci sequence, and it's named after the Italian mathematician who is credited with creating it, or discovering it. And how you get the next number is you simply add the two previous numbers before it. So 0 plus 1 would give you a 1. 1 plus 1 is a 2. 1 plus 2 a 3. 2 plus 3 a 5, and so on. So to get the next number after the 8, we would say 5 plus 8, and that's 13. So if you got 13, you were quite correct. And I hope to see you guys next time, and cheers. Bye. I love you.